close my email so I don't get interrupted. They call it special systems. If you guys remember when we talked about wireways, I told you between MC cable and EMT conduit, you have just covered close to 90% of the wiring methods in a commercial building. MC cable and EMT conduit. Add a little bit of PVC conduit, guys, to it for underground and rigid for severe physical protection, and you're done. Now, there are other wiring methods in NEC code book that's very important for special applications. We're going to touch on a few of them. So this chapter talks about, guys, metallic raceways and surface metallic and non-metallic raceways, multi-outlet assemblies. So these are the major part that we're going to be talking about: the metallic surface raceways and multi-outlet assembly. Load calculation for multi-outlet assembly. You guys know how we did the load calculation for multi-outlet assembly based on the length, if it's continuous or non-continuous. So with this, I'm going to move you very quick into a couple of things here. Pictures. Oops, where's my pictures? Here we go. Before I do that one, guys, I always, the way I teach that one, I always go to the NEC code book. So if you can go quick to the NEC code book and show you very interesting articles, I think it's really interesting for wireways, and then we'll go into the application of these. The first thing I want to show you guys, if you have your NEC code book open, we're going to go to metallic wireways. Okay, raceways, auxiliary gutters. We're going to go cellular, metallic wireways, non-metallic wireways, and raceways. Okay. There are, in the NEC code book, guys, there are the conduits and the cables, and then there's the raceways and the wireways. Anybody knows what the difference between a raceway and a wireway? Wireways come in, for the most part, in a square shape, cross-section area square. Raceways come in multiple different shapes and forms, in any form that you want to do it. Both of these guys are surface mounted. A lot of them are surface mounted. Great for remodeling. You get into a school that has been built in the 50s. You don't want to bust walls. You put raceways. You're looking at non-metallic raceway right here. If it's non-metallic raceway right here, you plug in all your receptacles in it. So the wireways, guys, are a special type of a raceway. I always think of it as a special type of raceway with some restrictions. Metallic. I'm gonna show you guys one little thing advantage of wireways. Uses permitted, not permitted. You can't use them in a severe physical protection areas or highly corrosive because they are non-metallic. So that's, other than that, it's a surface raceway. Metal wireway shall be permitted as follows for exposed work. I'm not going to go to the hazards where raceways are listed for wet location. You even can put them in wet location. Concealed spaces, extension. Part of it can be concealed, the part that doesn't open. So these are a few things of where you can use them. But let me show you the advantage of using that baby. Is the advantage is number of conductors and cross-sectional area right here. In my book, this is one of the most important things of use of that baby. If you look, first of all, I cannot fill it more than, can you guys see that? I can't fill a raceway more than 20%. Wireways, you cannot fill the wireway more than 20%. 20% fill on a wireway. When we talked about conduit, remember, guys, the conduit, the fill was in the conduit? 40%. So wireways, you can't fill more than 20% of them. Okay? The other thing, guys, the advantage is the rating. When you put, look at this. This is also another advantage. When you derate, Ashley, if you have a wireway, right here, metallic wireways, you can pull up to 30 hot conductors, 30, before you start derating. Is this an advantage or disadvantage? You guys see this as an advantage or disadvantage? It's an advantage when you have a 30 conductors that you cannot derate. So these are the most important thing I think about the wireways. You can pull up to 30 hots carrying conductors without derating. If you have a conduit, you have to do it if you pull more than 3. So highlight these ones. These are advantages of using wireways. Because a conduit is completely enclosed. A raceway has covers on it, so dissipation of heat is higher, is better in a raceway than in a wireway. Yeah, a raceway than in a conduit.
The code uses the term raceway, it seems like, for anything that contains conductors.
A conduit is also a raceway. Yeah. Yes. A conduit is also a raceway. Wireways. So wireways, as I said, is the only thing is the shape most of the time is going to be a square or rectangle shape. Okay, you can use them exposed, guys, and you can fill them up to 30 without derating. These are metallic wireways. Now I'm going to move you into the non-metallic wireways. Now, where would you use non-metallic wireways? First, where would you use wireways? Surface mounted extension for existing building, remodeling, and so forth. Yes.
So, Chad, to clarify, I'm just reading the definition in chapter 100.
Okay.
Raceway is a total is top. There are conduits, flexible.
It's
wireway is part of is like an EMT or
yeah. Raceway is a collective term. Raceway by itself, not surface raceway. It's a collective term that describes multiple conduits and multiple wire methods. If that makes sense. Wireways are a special type of a raceway.
Right. Yeah. Okay.
Special type.
Just helping myself.
It's good. No, a good point. Good point. Okay, we have doors and so forth. So where would we use them? I don't want to make you guys all about the raceways. Where would we use them? We use them, and as I said, surface mounted for the most part remodeling. Where insulation, conductor number 4 are larger, pulled through the conductors, you have to apply some other rules for it. But I'm picking certain things that I want you guys to know about them. Can I splice in a wireway? Yep, you can splice in a wireway, but please make sure you don't fill more than 75% when you splice in a wireway. Unlike conduits, where you cannot splice in a conduit. In a wireway, you can splice because it has a cover. You uncover it and you get access to your wireways. So these are the things that I think it's advantage of wireways. Non-metallic wireways, and I'm flying through these guys. Non-metallic wireways, the same as wireways, except the ideal location for this, Chris, is highly corrosive environment. Highly corrosive environment. You don't want remodeling for highly corrosive environment. You do not want any metallic. So you put wireways. The disadvantage of this one, guys, look where we can use them. Wet location, bring it on. Exposed work, we're subject to corrosion, is a great application for it. Not permitted in physical damage. If there's physical damage, you can't put it. Hazardous location with some limitation, you can't put it. So there's a few limitations where we cannot put it. I'm going to go directly into the number of conductors right in here. The drawback of this baby, to the current conductors up to and including the 20. Here's the drawback of this guys. So when you apply, you can't fill it. You can't fill the conduit more than 20%, exactly like the metallic one. No fill more than 20%. But you have to derate. The minute that you put 3 conductors or more in this conduit, you have to start derating. You have to start derating. So that's really the drawback of non-metallic wireways. Well, actually, this wasn't on our assembly. It was multi-out assembly. Here's the code we define multi-out assembly, guys. So I flew through 2 wiring methods. Wireways, metallic, non-metallic, for remodeling only. 20% fill. Derating for the metallic start at 30 conductors. For non-metallic at 3 or larger. Larger than 3 or more than 3, you have to derate. Multi-out assembly, guys, it's manufactured. Look how they define it. It's installation, article use, installation, blah, blah, blah. Permitted, it's manufactured. Multi-out assembly, it's a raceway that's manufactured. All the wires and all the receptacles have been pre-manufactured, right? Exactly like this one about in front of you. It comes pre-manufactured, pre-shaped, so you can use it in location. We have concentration of loads. Great application for an area that has concentration of load, exactly like you're in front of your desk. Multiple laptops, multiple things need to be plugged in. You put a multi-outlet or a multi-out assembly. So as my multi-out assembly, we did the calculation for that one. So you can get them in GFCI. You can get them in a lot of stuff. I'm going to move in from multi-out assembly, guys, into the raceways. I'm not going to talk about this type of raceway. I'm going to go all the way surface metallic raceways. Surface metallic raceways are different than wireways because they can come in every shape and every shape. It doesn't have to be square. You can get them in a lot of shapes. Metallic, you put them on a wall, use mostly for extension. You don't want to wire the whole building with it, expensive for extension of new wires. But what's the difference? What's the advantage of a metal raceways over the wireways? The advantage, guys, is you can fill them more than 20%. That's a major advantage for wireways. You can fill a wireway more than 20%. The raceway, the wireway is 20%. The raceways, metallic, you are limited. For the wireways, 20%. For the raceways, you don't have the limitation of 20%. Another advantage, guys, is also you can put higher voltages on them and so forth. Number of conductors, here's number of conductors in the raceway. So you can see it's a smaller article about them. Surface metal raceways. Okay, let's go to the number of conductors. Here you go. If you guys read through the number of conductors here, it will tell you the number of conductors in a raceway shall not be greater. The surface metal raceway shall not be greater than the number for which the raceway is designed. So how many conductors can I put in a raceway? Your answer would be, well, as many conductors as the manufacturer have designed it for. Who cares? It gives you a better wire method. You can add more conductors. But catch 22. If you are to fill it 20% like the wireway, and if the size is 4 inches, exceeds 4 square inches, and you are not carrying more than 3 hots, then you don't have to derate. Can you guys see that little exception here?
30 hots.
30 hot, 30 hots. So if you want to use, this becomes this side here, this part, if you do it this way here, it becomes a wireway. You can treat it exactly like a wireway. If you want to treat it like a wireway, no problem. You don't have to derate more than, after 30 you can derate. And 20% fill, you don't have to, but you have to maintain a 20% fill. No more than 20%. It has to be 2 by 2 to get you a square, at least 2 by 2. 2 by 2 is give you square inches or more, exceed 2 by 2. So it has to be like 2.5 by 2.5 or 2.5 by 3 or so. In this case, you're looking at it as a wireway. Who cares? Why do they have? Why does the code split them, guys? Because their characteristics is different. And remember it as raceways are superior to wireways. They can get you more conductors than them. But what's the drawback? If you go more than 30, guess what you need to do? Now you're going to start derating. If you go and if you fill more than 20%, you have to start derating. So if derating is not an issue, then raceway would be a great option for you. I'll show you a couple of pictures when we go to them.
Does that 20% only apply to the derating?
Yes. If you don't want to derate, if you do not want to derate, and you want to fill it more than 20%, then you don't have to. Then you can put as many conductors as you want. But if you limit the fill to 20%, and the cross-section area of the raceway to more than 4 square, and the number of conductors to less than 30 or less, then you do not have to do it. If you alter any one of these 3 things, then you get to do it. And I hate to, you guys being designer, for the apprentices, we go a lot over this. If you're a project manager, you need to know one little thing, which I hope you guys gonna be. That's your dream, to be a project manager, right? At one time, you got to be able to understand that there are different wiring methods in the code. This is a great application for schools, for example. Remodeling systems, that would be a great application. Surface mounted. Okay, so I'm not going through all the details. I'm just giving you what affects us, the ambiguity and so forth. Okay, so that's my surface raceways. Now, non-metallic. Every time, Nick, you hear the word non-metallic, always remember highly corrosive environment. Every time the word comes to you, if it's conduit or raceway or wireway, non-metallic always associated with highly corrosive environment. Because no matter what you put in a highly corrosive environment, you're going to lose it for corrosion. Okay, so where do you think a non-metallic wearway could be used? Very wet, highly corrosive environment, that's all. But look at the drawback of that baby. There's a big drawback for them without getting used. There's a problem with physical protection, limitation on the voltage here that you can use on it, up to 300 volt. So it's limited to 208, 120. Sizes and number of conductors. Here's my favorite for us being designers, is that one here. So if you guys look at this, it says number of conductors or cable installed in raceways shall not be greater than the number of which the raceway is designed for. Cable shall be permitted to be installed where it's subject not. Okay, so that's basically, and the derating, you have to derate. You have to derate from the get-go. So this is the drawback of this conduit, guys, where you have to derate for any size. So for example, that wireway here, you're looking at surface, here's a non-metallic surface mounted raceway right here. If I pull more than 3 conductors, I have to derate because it's non-metallic. More than 3 conductors. Had this been metallic, then you can go up to 30. So anyway, that's the major thing that I want to highlight. What's the advantage of all raceways and wireways, guys? You can splice inside them. Unlike conduits, where you can't splice, you can put devices inside them too. Sections and put devices inside them with a special section. So it's a whole complete system. Okay, and I want to stop right here, guys, for the code and move you directly into my pictures here. Here's what we're talking about, guys. You are looking at a raceway, metallic or non-metallic raceway. Can you guys see that there's the bottom and there's a cover at the top of it and snaps right on the top of it? Okay. A lot of hardware that comes with it. Here's how they use, they call them molds sometimes too. Here's a non-metallic surface mounted raceway. I want to remind you guys, it comes with its own boxes and angles and switch boxes, fixture box. It's a whole wiring method. A whole wiring method. I'm sure if you wired residential, you went to call them mold, you can go buy them, and if you don't want to fish things, it looks ugly though in residential, you can put it on the sheetrock and mount and do the whole system. That's the baby, the residential part of it. But the commercial part of it, it could be a complete big, thick, wide stuff that you can install anywhere.
Is it also known as wire mold?
Wire mold, one type of it. Any question, guys, about this system? What's the drawback on this? You have to derate. If it's non-metallic, you have to always to derate. Okay, so that is a wiring method. Here's another way of wiring it, guys. If you can see it, is you have your boxes, you install receptacles, connectors, and all this good stuff. Complete system in that wireways. Raceways. You can put a lot of, in the raceways, guys, you can put a lot of part of receptacles, or you can go into the multi-outlet assembly. Now, any question about wireways, metallic or non-metallic? Summarize. You use them for remodeling only, metallic in anywhere, non-metallic, highly corrosive environment. Non-metallic, guys, you can fill them up to 30 without derating. You start filling more than 30 current conductors, you have to derate. Don't use them as general wiring methods unless you're doing remodeling. That will summarize it. Any question, guys? Can I go through the wireway to a wall? Can I go to a wall? Like if I have this wireway, can I go through the wall? Yeah, no problem. As long as the section that goes through the wall is not the cover. It's non-covered section. So they have a special section that allows you to go high from this side, from the other side. This side will open, the other side will open, and the one inside the wall is just complete, like a conduit almost. So you can't go through walls. Okay, now a special type of raceways, guys, is multi-outlet assembly. The smarter than Chad, they took a raceway right in front of you and they pre-manufactured receptacles or switches or low voltage parts, and they put them in the raceway and they call them multi-outlet assembly. So to make it easier for installation, you go plug in the surface mounted multi-out assembly and wire it, hardwired it or plugged it in. The one that in the front of you, Chris, is plugged in, but you can also have a hardwire. You can have, this is multi-out assembly, you can have low voltage, high, two sections. You guys have them. You can have one section for high voltage, one section for low voltage on the multi-outlet assembly. So what's the difference? Multi-outlet assembly, it's pre-manufactured with all the devices in it. Raceways and wireways, we have to put the boxes for the devices and as well as the system. The boxes and the conduits and so forth. The way we calculate them, guys, if you remember, every 5 feet we give it 180 volt if it's non-continuous, and if it's continuous, what do? Every 1 foot we give it 180 volt. They place them for the most part. Again, it goes different designs, but you put your receptacle and so forth. Okay, multi-outlet assembly, guys. Two things. They talk about two chambers. You can have one chamber for high voltage, one chamber for low voltage on them. Better explanation. In the multi-outlet assembly, this is my favorite. If I can get you guys, if you have 208/120 volt system, and you have a multi-outlet assembly in a commercial building, this is how they wire them. This is typical. Dustin, my friend, hiding over there. This is typical also for the furniture. Do you guys remember the furniture that we have in our project, right? Can I say yes, Chad? I remember the furniture. I know it's Friday. The furniture. Remember when we said there are 3 receptacles in the furniture, and they wire them, they bring phase A to 1, phase B to 2, phase C to the third one. This is very typical. So there are 2 ways of doing it. Either you take one receptacle from every phase. So this one would be, will be phase A, phase B, phase C, phase A, phase B, phase C, phase A, phase B, and then phase C will be here. In return, if this is circuit 1, 3, and 5, this receptacle will be fit from circuit 1, 3, 5, and 1, 3, 5, 1, 3, 5. This is the best application. Anybody can tell me why? Because in every location, you have 3 circuits. Every cubicle has 3 circuits. It's highly unlikely that you're going to overload in one cubicle 3 circuits. For example, Nick is a hardworking individual, and he sits at Mashad Kuli work all the time, and he's plugging all his equipment, right? On the other hand, Aladipo is lousy, and he doesn't show up in his cubicle, and his cubicle is always empty, right? So if Nick is plugging into 3 receptacles, these 3 receptacles will be from 3 circuits. So he's not overloading one circuit, one receptacle fit from one circuit only. It takes into consideration the diversity of the load, guys. Long story short, if you do it this way, it would not overload your circuits, 1 amp circuits. The best way to do it is this way. Now this is expensive, as you can see, because the wires are going all over. A cheaper way of doing multi-outlet assembly or even wiring furniture, guys, a cheaper way is to use phase A for a group of them, 1, 2, 3, 4, 5, up to, remember we said up to 6 in our calculation. So this is, in this case, is 5 of them. Then another phase B here and phase C here, and that will make, this is circuit 1, and this will be circuit 3, and this will be circuit what? 5. And granted, this will continue and all this good stuff. Any question, guys, about the wiring? I can't emphasize getting you guys to understand how you wire lights or receptacle with 3 phase. Can I get everybody to give me just, especially this, thumbs up, Chad? Yeah, we know exactly how it's wired. Phil, my friend, makes sense? Thank you, buddy. I'll buy you a chicken one day. Okay, so now, if I, excuse me, if I go get rid of these receptacles and put lights, would that even make a difference? I can put lights here. I can put, and make it a lighting system. I can put, instead of, especially the top, instead of 6 receptacles, 1, 2, 3, 4, 5 lights, and feed them from 1 circuit. How, my friend? That's exactly what you guys did with Chad when you were circuiting. You're grabbing 1 phase and circuiting 1 areas for it, shared with a neutral. Now we're sharing a neutral. Yesterday we talked about harmonic, and we said harmonic are nasty, nasty, nasty bad news. So what do you do if you don't want to share a neutral? Can you guys tell me that, Chad? We know we pull a new neutral with every circuit. So if you want to, like in one application for a computer room, we said we need a neutral with every circuit. So what do you do, guys? Then in a case like this, you're going to grab that neutral from here and put neutral and break it here. and grab the neutral from here and put the neutral here, break it. And the same thing for these. You're going to grab one more neutral for all the circuit A, right? And another neutral, we're going to bring it for circuit C. 1, 2, and somewhere here. So we'll grab 3 neutrals. Any question, guys? Any question about this wiring? That's what I really want to emphasize more than anything else. Okay. Even though what I showed you was for multi-out assembly, typical wiring for a lot of things. Multi-out assembly, guys, you can go, you can transfer from one wiring method to another. Okay, now moving from wireways, that's not enough for you. Here's another wiring method. This wiring method, guys, is underground. It's concrete encased. What do they call it? Concrete encased underground system. Underfloor raceways. They call them underfloor raceways. And Article 390 apply to this wiring method. The way this system works, this is the best way of wiring in a concrete. The best wiring method for concrete. What you do is you put all use channels assembly. You use 2 channels. Anybody knows why 2 channels here? Now remember, all this will be buried in concrete. Because one we can use the high voltage and one for low voltage, right? As in communication and data, and the other one for the high voltage. So you build all these channels, guys, 2 of them going, well, in this case, in this case, vertical elbows. Okay, so let's assume that there's a barrier here between them. You have the J boxes, you have your J boxes, you have device boxes completely embedded in the concrete. Completely embedded in the concrete. Where would you use this system? If you have a concrete slab and the office is right in the middle of that, like open office, and you want to put receptacles in the open office. There's no walls around you. How would you do that? There are 2 ways. Either you put PVC conduit encased in concrete and put a device boxes. That's one way. The other way is you use a complete standalone system with all the fittings that comes with it. That's meant for concrete encased underfloor raceways, basically to be buried in concrete. Any question, guys, about this system? In our project, where would you use this system in our project? The only place that you can use this one is in the open office. You will be fooled to use this system if you can put things in the walls because it's expensive. If you have a complete open office, guys, open area, no walls, and you don't want to put these ugly power poles standing in here, right? You don't want to put them because the architects hate them and they're in your vision. You come from underground, in the concrete, and you put all your devices. You can have J boxes, you can have receptacles, you can have low voltage parts, all in this system.
It's a big deal with groundwater, though.
Well, you have to pull an equipment ground conductor with it.
No, groundwater. If you put those on a ground level, you get big troubles.
You mean the slab?
Water. Is it weather? Water. No, it's not going to be water. No, that. But you've got to be concerned about water.
Getting seeping into it.
Yes.
Okay, well, if you put it would it be different than any conduit that has conductors outside?
For PVC, you much less likely
To seep water in them.
Because
If you have water that low in your building and under the concrete,
I mean, there's lots of options
yeah.
that are laid on.
rather than slab,
You'll
yeah.
drive down 394
Yeah.
and you'll see
It could be, you don't want them to fill with water, what you say, seeping into. I'm sure they have something to prevent that though. I've never wired it, so. Here's a couple of outlets, guys, devices that you can use with this system. Couple of things. For those of you like Ashley, who is an electrician, they want to install it. Look at the hardware that comes to make a receptacle like this guy. All these, this is the rough-in. You did your rough-in in the hole, you put the covers, and they allow you to cut it, guys, because you can, it might be higher or lower than the concrete slab. Then they allow you a little bit to adjust it. So there's the box body and the inner ring and the adjustment ring and the casket for water. And a duplicate receptacle, all the stuff that coming into it. You see them all the time in the ground. Here's how they do them. You know how you cut them and put them all together and all this good stuff with the hardware, and then bury them with the or cover them with the concrete. And this just talks about adjustment, guys. You don't have to have the exact height because concrete might be higher or lower. It allows you to adjust it and cut it in the field. You guys are designers. This will be for FYI. Okay, any question, guys? Any question about this wiring system? And not to bug you, but I would like you, probably this will be the last time, my friends, that you will go into this wiring system. I want you guys to go look at it. Look in the NEC code book. And this was, what did we say? It was 390. So if you guys go to 390, here's what the NEC code talks about it in 390. Oops, where was I? Did I flip it? 390, right here. Underfloor raceway. Covers use and installation of underfloor raceways. Maximum fill. Chris, how much can you fill out of this raceway? Look at that one. How much you can fill out of this raceway? 40%. Versus the raceways, metallic raceways was what? 20%. So there's more. Splices shall be made in only junction boxes because it's full of concrete. Disconnect, all this good stuff, junction boxes, cable trays. So that's basically about it in terms of definitions. Here's how they define it: a raceway and associated components designed and intended for installation beneath or flush with the surface of a floor for the installation of cables and electrical equipment. Use is permitted. Let me see about what you said, Chris, if they say. The installation shall be permitted beneath the surface of concrete or other flooring material or in office occupancy where laid flush with the concrete floor and covered with different type of covers. Okay, use not permitted. Shall not be used where subject to corrosion, subject to corrosive vapors, and that's classified location unless made blah blah. So basically, almost you can use it anywhere else except with some hazardous location. Okay, so that's basically it in terms of that baby. Underground raceways. Ambiguity of the conductors. Look at that. When you put these conductors, where you get to find the ambiguity adjustment factor shall apply to conductor installed in this raceway. So if you put THHN there, 3 of them or more, you have to go adjust them. Any question, guys, about this raceway before we leave it? Any question? Who cares? If you're a project manager, you have to at least know of them. You know, that's an option that you can use this raceway. Comments, questions? Okay, so that's the last thing, guys, in this chapter was about the fire alarm system. The last thing was about the fire alarm system. We're going to have a speaker. Oops, I don't want to do a. It's just more here. Next week, I believe. Next week, Chris. Next week we have week 7. Yeah. Next week, guys, we're going to have a fire alarm security speakers. This is a riser for your fire alarm panel. For your fire alarm panel, we haven't done fire alarm panel, so please read it. The only thing I want to tell you right now is the system that we have is going to have your fire alarm control panel right in here. You're going to have a lot of detectors. All these are input devices. Your input devices, and you're going to have output devices. These are the eyes and the ears of the fire alarm system. Look how we're jumping from raceway to fire alarm system. Interesting. But I promise you guys will have a good speakers and good information about this. But for the time being, I want you to know the smoke detector, heat detector, all these detectors, pull station, the fire alarm system, that you bring them to the fire alarm control panel. And out of the fire alarm control panel, there will be decisions made and sent via, for the most part, horn strobe like that one that you're looking at, a horn strobe. So it warns the people of the existence of a fire. And I'm going to stop at that one here, at least at this point. Any comments? Anybody has comments, guys, about this chapter? I can't emphasize when you guys becoming project managers, especially in an electrical contractor firm, you have to understand these. These are the wiring methods that we went through. I went through them fast, but because you guys are not electricians, we teach them for apprentices in details how to wire them. But you're not going to be wiring them. At least you need to be aware that they exist and how many conductors you can pull in them, right? Because that's what we care about. Any comments, any questions? Gosh, it's Friday. Okay. Thank you, thank you, thank you. All right. let's just go here. Moving on, guys, on this chapter, we're going to be talking, Phil. When we move from now on, we're going to be taking this project that we have in this book and reviewing it. Really, a lot of chapters going to be taking this project and reviewing it. In this chapter, they're taking drawing upper level. And what I'm going to do is just go look at it and highlight a few things and let you guys finish your project. How about that? Cool? So if you look at that level, oops, where are we here? 10. Okay, here's what they're looking at, guys. And you have this one in your sheet. This is the upper level. There's the real estate office. I don't know if you guys can see that one. Your real estate office and the beauty deal here. And the insurance. Where's the insurance? And the insurance office right in here. So it's a layout of multi-occupancy building. They call it multi-occupancy building. It shows the power and the receptacle. A few things I'm going to highlight in this. Remember, guys, with the multi-outlet assembly that we were talking about, they're doing a multi-outlet assembly right in here and right in here. This is, if you look at that, they have a multi-outlet assembly that's fit from 3-phase. With multiple receptacle in this area in this insurance office. That's what I want to highlight. Now, is this the only way of doing it? No. Tao, because you and Ashley, you guys are so good with Revit, I want to remind you something for next quarter. We're not using multi-outlet assembly this quarter. Next quarter, we're going to have a multi-outlet assembly exactly like this one. And you guys are going to grab one and put it in Revit. And the family that we have right now in Revit, you're going to see, you're going to drop it. It looks like this. You grab one end and you stretch it to match how long you want it to go. So that's the family that we have. So please pay attention to the circuit that's coming out of it. We're not doing it now, but we will. So it's fit from all these circuits. That's what I want to bring your attention to. The second one that I want to bring your attention to, guys, the receptacles on this side that have an isolated ground receptacle. In that office, they have because of computer room, they have isolated ground receptacles in that area. Like we asked in our area an isolated ground receptacle, isolated grounding system, as well as a second neutral. And the last thing I want to mention, guys, is the lights. For the lights, I'm going to go zoom into. So Nick, Chris, my friend, yesterday we were talking about the naming convention. They did the spaghetti here, guys. They did spaghetti, but look at this fixture. We don't want to do spaghetti. We didn't do spaghetti in our project. So G, this is a G, right? G stands for what? Type of fixture G. And what do you think C stands for? Right next to it. The switch. I can't see where they put their circuit though. I don't know if they put A, B, C. And here, they named them exactly like you did. A, B, and C. In one area, you start with smaller letters, A, B, C, D. And then if you move to a different area, you start with the same letters again. So they have A, B, and C. And you can see this picture is going to be from A, B, and they stagger them. Can you guys see how they did? A, B, and C. Exactly what you did. Here's A, B, here's C, and A, B, C, and A, B, C. Can you guys see how they did them? Stagger them, A, B, C, A, B, C, A, B, C. You can do that. Dustin, what I told you, the poor man's job is grab chunk of them, one row, and put it on A. You could do it in multiple ways. One way that you can do it, it might be cheaper, is to put this one in switch A, this one switch B, and this one on switch C, right? What they decided to do, they want 3 levels of lighting everywhere. Can you guys see how switching decide how do you want to use the building? Do you want to, this is an open office here. People are sitting there all the time. So they want to have 3 levels of lighting, 3 levels. So if everybody wants a lot of light, you turn all of them on. So you have more light. Level 1 is a lot of light. Level 2 is you switch one of them off. Level 3, you switch the second one off. Can you see that you have 3 levels of light, the way they design it? Is this the only way of designing the switching? No. A lot of open offices are done this way. You stagger them. I don't know here, for example, in our area here, being a classroom, the first thing you think when you do a classroom is these have to be on what? One circuit because of the projector. Anyway, so I wanted to highlight this one. Any comments, guys, about this? This is exactly what you're doing right now. The other thing I want you to look at, Nick, my friend, they are using a floor receptacles. Can you guys see the floor receptacle? I know we're done with power. They're using floor receptacles. That's exactly, Chris, what they use for these underfloor raceway. They have a floor receptacles. Inside that floor box, they have a receptacle and phone and data. 2 sections. 1 section for the low voltage, 1 for the high voltage. Any question, guys, about this? Any question? So it's really, that's the insurance office. They put a lot of isolated ground in a lot of stuff here because they want to isolate ground. The last thing I want to mention here is the emergency light. We talked about emergency lights, guys. Can't see it here. So they have an emergency lights. Did they dedicate them as emergency lights in one area? Okay, let me close that one. I don't know what they use in this area as an emergency. Do you see, guys, EM in any of these fixtures? They might use a bug guys here. Okay, in this office, for example, they use, can you guys see, Nick, my friend, you see the EM right next to this fixture? This means this fixture has a battery in it, and actually it's going to act as both normal light and emergency light. If you guys can see that little baby here. Oops. Oh, that's cool. Okay. That will make me, oh no, now I'm lighting. I don't want to light. I want the other cool stuff. Okay, so that's basically, that fixture here will allow you to do the your emergency light.
So the whole fixture will
It will,
on all the time.
no, it will be, well, depending,
How many lamps is it? Well, it depends on the first floor.
well, there's so many ways of doing it. And I honestly don't know exactly what they did, but there's so many ways of doing it. One way is to have a battery backup inside that fixture. And then when you turn the fixture, you can switch the fixture on and off, no problem. But if the power is to go off in the area, there's a little relay inside the fixture that switches you to the battery. Only if the circuit breaker trips. Only. That happens only if the circuit breaker trips. If you turn the light off, it wouldn't turn it on again. Only if the circuit breaker trips. So what they do is they have a sensor. They take a voltage from the circuit breaker ahead of the switch and bring it to that relay. And the relay is just looking at the voltage that's coming out of the panel. Is the voltage there? Yep, stay as is. Is the voltage? Yep, stay. The minute that it loses the voltage from the panel, because somebody turned the circuit breaker off, or a storm took down the transmission line or distribution line, that's the voltage will go off. There's a tiny little relay inside it, switch you to the batteries.
So it'd be called an emergency fixture with battery backup.
With battery backup. Yeah, it's like the bug guys, exactly the bug guys. Except the bug guys will be, in a case like this, well, the bug guys will come only if there's an emergency. This one will be on all the time, on with a switch. But the minute the switch goes off, the power goes off, it will switch you to the battery inside it. Or it could switch you to a generator too, if you have a generator. So that's what we're going to be talking about, guys, in terms of emergency. I want to take you to the what do you say? Beauty? Say it. Beauty what? What's this? Salon?
Salon?
Why not saloon?
Well, see, normally the saloon is for the guys and the salon's for the women.
Yeah, you go
I'm
to the
not
saloon
sure.
while life's at the salon.
That's kind of.
You guys are scary. Okay. Okay, so for this, my friends, I will highlight just a couple of fixtures, how they wire them. Fixture E, we don't look at the Nick. Can you guys see how they didn't label this switch right in here? This switch, it's not labeled because there's no need for it. It's already tied to it. You know, it's clear. So you don't have to label it if it's clear. They have a couple of emergency lights here. I want to highlight, as a matter of fact, so there's so many ways of doing it, but I want to highlight the exit signs here because we're working on the exit signs. If you do me a favor, I want you guys to look at the exit signs that they have. Can you see that the exit signs, they're directing the traffic to the exit signs? I'm going to be asking you guys to put exit signs. So people come out of here and it will direct them all the way to go down to the exit. If you come, there is nothing here because if you're in this area, the only outlet, the only way out is here. So, and if you're in this office, the only outlet, I guess, is going to get you out of here to here, so you can see the traffic to get you out. The same thing here in this office, your out is here. So you can see how all the offices can get into, you can see the sign that tells you go this way in a case of emergency, the exit signs. Any questions, any comments? Exit signs, emergency lights, the way they circuit them, the type of the fixture that they use. There's so many ways of doing it, guys. I know we picked different fixtures and some similar, some different than what they picked for this project. We will be going into, guys, elevator room and all the stuff as we go move forward. GFCI receptacle in this area because of the sink. You can see all these receptacles are GFCI because there's sinks there. I don't know if you guys can see the real estate office has an emergency lighting fixture here to direct the traffic. This is, I want to highlight this one. Do you guys remember these two where they placed the emergency lighting fixture? Can I have you guys for 1 second? You're in the insurance office and they want you to be able to get out. So I'm just going to draw a line and show you the traffic. Look how they put one here and they put one here and they put one here. That's what they call it, the egress path out of this office. What is an egress path? That you're going to dedicate a path of 2 feet or 4 feet and get the people safely, let this path and let the people safely out of the room. So let me draw that. That's what you guys are going to do with you. So the path for this, the way they envision the path is to go this way out, and this way. So that's the path. That's the path that they want to lit. And Rob, my friend, with visual, we can actually design this path, and we do a calculation, and by building code, you have to maintain 1 foot candle. Now 1 foot candle is nothing, but enough to get you out of this. Now you're not going to sit there and read the newspaper. So you have to maintain a 1 foot candle into this path. Talk about 4 feet, direct the traffic all the way. So if you lose power, the people will be able to see clearly. Here's my path coming all the way. Anywhere in this office, anywhere from this office, come to this path and exit here. And then there's an emergency light. I don't know if you guys can see. It continues here all the way down. The path out of this continues all the way down, right? And here's an emergency fixture here, an emergency fixture here. Can you see that? An emergency fixture here. Can you see how it's directing? Everybody can see how it's directing the traffic out of this area. I don't think that the salon have anything in it. I can't see where they put. I don't think they put a fixture there, because maybe it's just one room. There's an emergency if you're in the bathroom, Chris, my friend, you don't want to get stuck. Also, our friends, the female, we don't want to get stuck there. So the same thing, the path out of here, tie into the emergency. That's exactly what I want to highlight, the emergency path. Can you guys see what they do with the emergency lights? You dedicate an area like this. If I want to put one guy right in this area here, that will lit this as an egress path for me, or one of these lights, and then we'll channel us all the way out of this room. Any comments, guys, about the emergency egress path? And in the egress path, you can see there's signs that direct you, say, oh, by the way, go this way, don't go this way, directing you out of the building. to the outside. Any question, guys? That's really want to emphasize, because we're doing right now the emergency, want to emphasize the egress path for this building. What else do we have here? Okay, so that's about it. We'll keep visiting these guys as we go through the last thing in this I'm going to go is here they have water heaters. And this is the wiring diagram for a water heater. For water heater, I want to highlight a few things, guys. It's an appliance. If you have a water heater, it is an appliance, believe it or not. And I need to have a disconnect for my appliance. Can you guys see that? My disconnect for my appliance. Did you do that? Okay. So I just want to highlight a few things here, guys. You have to have an overconduction device for the appliances, 1.5 times full load current of the appliance. You need to have a conductor, 1.25 times full load current of the water heater. You need to have a disconnect on that one. I size it there to 1.15 times full load current of that appliances. What else? So you sized a water heater. This is how you size a water heater. So if you find the kW, say it's 30 kW, since it's a resistive load, the kW equal to the kVA, then from the 30 kW, I don't want to do the math on that one, you find A, you take the 30 divided by 1.73 times 208 system, and then you find the amps, and that will be your amps, don't forget the K. You multiply the amps by 1.25, size the conductor, multiplied by 1.5, size overconduction device, and disconnect is 1.15. If the water heater is within sight of the circuit breaker, so I have my water heater three-phase sitting right here, and my panel is here, I don't need to have a disconnect, because the circuit breaker acts as your disconnect. All this junk or stuff is inside the water heater control system, so we're not worried too much about it. What they ask us to do, Chris, is to come over here and provide. This is where we interface with them, really, right in here. From here out, we bring cables and put the disconnect and so forth. Any question, guys, about the water heater? Why water heater? Because water heater is an appliance. It doesn't have a motor on it, so they treat it 1.5. And if you don't believe me, I don't know if you guys can see you have it in yours. There's an article 422. We visited that article many times. Article 422, appliances.
So in this case, the wiring does not have to match the overcurrent section.
It does.
Oh, according to your time.
Well, when you do the calculation.
FLC times 1.25 versus the constant times 1.5.
Well, when you do your math, there's an example in the book, as a matter of fact. When you do your math, suppose that you end up with number 12 here, AWG, and overcurrent protection device of number 25, N. Okay? Suppose that's what you end up with, right? There's one little problem. You have fully protected the water heater based on this. Fully protected the water heater based on this. Fully protected. But there's one little problem. The conductor is not fully protected. So because of the conductor, you need to protect the conductor also, not just the water heater. This calculation can get you the protection of the water heater. I'm satisfied. Now, but also the overprotection device has another function, supposed to protect the conductors. In a case like this, the conductor is not protected because there's limitation on how much you can, overprotection device you can put number 12. So you have to go up this baby. You have two options. Well, you can either lower this to 20 amps, but you're taking a chance that this one might trip it. Okay? Most of us do the other option because it's a safer, and they go and up this one into what? Number 10. Why? Because number 10 is allowed by code to be landed. You can protect it to up to 25 or 30 amps or less. This only for appliances that doesn't have motors. If it's a motor, had this been a fan, what you have done here is perfect. Only for appliances that doesn't have a motor. You're absolutely right. But you see where I wish they just say 1.25, but what they want to do the 1.5 here because of the inrush. They don't want to take a chance that the circuit breaker will trip because of the inrush of that guy. That they up it. At the same time, you need to find some type of protection for the conductor though. Instead of having two, one for this and one for, here's what I could do. I could have, now you open the can of worms. I could have fuses here, and I can make my fuses 25 amps fuses, right in here. And I can put a 20 amp circuit breaker here. But also I'm taking a chance of what? Tripping that one on starting that one. So,
Looking at the map, that's
yep.
Yeah,
Yes, sir.
who's responsible, now we've got a maintenance electrician, are they responsible for understanding the wiring that
Inside here,
the wire, inside the water heater?
maintenance electrician are, construction electrician not. They're in Minnesota, and I'm sure also in a lot of other states. There are two types of electricians, guys. Well, if they know if you're an electrician, and if you know how to do it, you can do it. But here's what the division, basically labor division happens. If you're a construction electrician, most of the people, their skills stop at this point right here. I'll go, if it's not working, for example, what are we going to do?
But
I'll
they
check.
could look at it.
Voltage. Yeah, yes, they should, but inside the guts here, it gets so complicated sometimes that needs specialized people for it. Take this furnace, the furnace. I'm a master electrician. I know exactly how the furnace, and I tell you, the control circuit and the power circuit coming to a furnace, exactly how it works. When I trouble my own, I go, is the voltage there? Yup. Is the control voltage up there? It took me 3 times troubleshooting it because, and you know what the mistake was as? There's a controller, a brain, right here, a controller that right here, and it took the technician from Mini-Gas for 3 trips to discover that the controller in my furnace that I was trying to troubleshoot, everything is working. It's just crap. It's electronic on it and crap. 3 times to come and fix something and say, oh, it's working now, and then it goes down. So, long story short, guys, it becomes so specialized that water heaters and furnaces and equipment become specialty for a certain group of people. Maintenance electrician, there's a lot of companies have maintenance electrician that they train them into troubleshooting the whole system. They specialize in the equipment and so forth. Those are really very competent people because they're hired, like you're sitting here at Dunwoody and all what you do maintaining all the systems. So you know your equipment really good. You don't go from one company to another.
Okay, so maintenance electricians are normally
Station.
Like, well, I know the airport has a lot of.
Absolutely. Those guys, they know their equipment really good. Because they don't, the problem with construction electrician is they go from job to job to job to job, they finish it and they don't visit the place again. So how are you going to maintain, if you have a maintenance electrician that have been there for 10 years, they know the inside and the outside of the equipment. So Nick, next time you go to the airport and you need really good information, make sure you find a good maintenance electrician. They can give you the history, not just what the equipment is, the history of the equipment.
Yes, there'll be no yes or no questions for that. Okay.
No, not like yeah, will they be like chatty all the time? They like to trick the engineers though.
Oh, yeah, I'm sure they will.
Any questions about this? Typical for all of our hearers. Had this been a single phase, no problem. 3 phase, no problem. 480, no problem. 120, no problem, and so forth. So that's all I have for you. Any comments, any questions for Chad? Okay. Thank you guys, and we'll focus on the project.